is when you see a manufacturer and they quote tensile, they're quoting this number. It's the highest possible number, whether it's brittle and it broke, or it stretched and it got a little stronger, or it was ductile and it stretched a lot, but it did get a little bit stronger. It doesn't matter. They're always going to quote that highest number. That number has some meaning, but without knowing some of these other things, it doesn't tell the whole story. And that's kind of important because you can have a cheap file. We all use cheap files in our, in our workshops. You drop a cheap file and it breaks, and that file had a 200,000 tensile as opposed to the chromoly 100,000. You dropped it, it broke. Why? Because it had no ability to do any kind of stretch and tear with that force. Clearly, that's why you don't make tubes out of the same material that you make files out of. If you did, the first time you hit a curb, you'd be in deep trouble. So what we want with bicycle tubing is we want a certain amount of ductility, and we'll go further with that. What we really want to talk about with bicycle tubing is toughness, and toughness is kind of it's really a balance between getting the most that you can get here and getting some of this, and the way toughness is really defined is the area underneath this is the total force. So really what you're looking for bicycle tubes is the one that's going to have a lot of area. So that means you want this area where it's stretched, it's being, you don't want it to fail immediately. You want it to stretch because you're looking for the most area underneath this curve. That's what really defines the toughness. So if you're on page 2, look at the bottom, and I've given some examples. Example to compare and contrast: mild steel. The energy to fracture mild steel could be 1,000 to 1,000,000 times that required to break glass. Now, what I'm saying here is if you had a glass tube, if you slowly loaded it, you could put the same load as you could with something that's made out of steel. But if you whacked it with a hammer, we know which one would fail. And so what we're saying here is that toughness matters with tubes for bicycles. And so you can have materials that have really high numbers in terms of what they're called out as tensile numbers. And even in the bicycle industry, we have some of this going on where there are some numbers that are really, really high, but in practice they don't work quite the way they're pitched to work. So that's kind of what we're trying to get through here. Or example 2, high tensile steels like knife blades. Well, why do you want a knife blade to have such a high tensile? Because you want to hold a really, really good edge. Once you sharpen it up and it'll shave hairs on your arm, you don't want to have to go back and resharpen that every 2 or 3 days. You want it to hold an edge. So in a case like that, you really want that hardness. But if you stick it in a hole in the wooden floor and you move it over, it's going to break in a lot of cases. Now, some of the knife makers are really smart, and they forge a hard piece with a more ductile backbone, and they do a lot of work to try to get around that, but that's a different story. Connecting rods for motorsports. This is one that a lot of people can kind of identify with. With race cars, one of the things that you want is you want things to stay dimensionally together, and then we've all seen these engines that are really high performance engines that something happens. Either they over rev them and something goes through a piston head, or if they're drag race cars with nitro motors and they have too much compression, they blow everything up. When that happens, to keep from destroying a motor, you don't want that connecting rod to snap. You want it to bend and take a huge amount of force. So it's kind of the same thing there. You don't want the knife blade, and so a certain amount of, you try to make these things as light as you can because they're reciprocating, but you still have to have some toughness to go with that.